So we're starting with two charges, one positive and one negative, each measuring 4 microcoulombs, and they're at a radius of 2 millimeters apart. And then a force is going to move those charges to be 4 millimeters apart without changing the charge whatsoever. And our question is, how does the energy in our system change and by how much? So we figured this out by calculating the energy before and after the movement. And this is done with the potential energy equals Ke times charge 1 times charge 2 divided by the radius. And when you plug in the numbers here for the first equation, positive 4 microcoulombs and negative 4 microcoulombs divided by 2 millimeters, you get a result of negative 71.92 joules. And if we do that same equation for after the charges have been moved apart, it's the same numbers but substituting in 4 millimeters instead of 2. And our result is now negative 35.96 joules. So we can see that we have more energy in our system, and this is because since the charges were pulled away, they want to be attracted to each other. So now to see how much energy has changed in our system, we're just going to do final energy minus initial energy. So negative 35.96 minus a negative 71.92 joules results in a positive 35.96 joules, which means overall our system has energy added to it.
Okay, so for part B, we have two plates that are parallel that are 2 millimeters apart. The positive plate has a charge of 4 times 10 to the negative 3 coulombs, while the negatively charged plate has a charge of negative 4 times 10 to the negative 3 coulombs. And we want to try and find the capacitance for a pair of parallel plates that are 4 millimeters apart, where the charges are the same. So we are given the initial capacitance of the first set of parallel plates, which is equal to 4 times 10 to the negative 3 farads. And so what we can do is we can use the equation C is equal to epsilon naught times the area divided by the distance. And since epsilon naught is a constant, that doesn't change and the areas don't change. The only thing that's changing is the distance between the plates. We know that the C final is equal to 1/2 of C initial, which means that C final is equal to 2.0 times 10 to the negative 3 farads. So once we found this, we can use this to calculate the change of potential energy. So first we'll find the initial potential energy by using the equation U is equal to Q squared divided by 2C. Now by using this and using the initial capacitance, we calculate U initial to be 2 times 10 to the negative 3 joules. Now to find the U final, we set this equal to the same equation, Q squared divided by 2C, and this time you use the final capacitance to calculate the potential energy final to be equal to 4 times 10 to the negative 3 joules. Now once we have our initial and our final potential energy, we can use this to find the change in potential energy by setting U final minus U initial to be equal to our potential energy values, which we find to be equal to 2 times 10 to the negative 3 joules, which means that energy has been added to the system.